So in this video actually I'll be explaining NumPy and its modules. In the previous one we saw the why NumPy is required when already like the array module or the list already exists and stuff. Okay, so now we know that like NumPy is basically a library that we use in order to store large arrays, right? So how do you get started now? If let's say if you wanted to create an array of 10 numbers in it, uh, in list in like normal way we would just say list of range 10. That gives you a list which contains like 10 elements, right? To create a numpy array, all you have to do is just call the numpy array function and pass this list to it, and then it returns you back the numpy array with all the numbers inside, right? So you got a numpy array right now. Okay. But one thing that you have to know is when you call this function, right? A list can basically contain any type of items inside. Like the first one can be an integer, the second one can be a float, third can be a dictionary and stuff. But you can't do that with when you call it with a numpy array. Uh, like all elements like should be numbers first of all. Okay, so at least in this example we'll keep like it should all be numbers. It can be int or float, but if you keep it to int and float, right? Let's say like this in this example here you can see that we have 1 2 3 then 2.7 and 69.98. So you have two floating point numbers and three normal integers. So if you were to create a numpy array out of this, numpy will by default upcast it, making that everything is a float. So it will become 1.0 2.0 3.0 2.7 69.98. As you can see it did that. You can see that float, that point, to indicate that it is a floating point number. Or while creating the array only you can specify that, hey, no, I want everything as an integer itself. That you can do by just calling the numpy np.array, pass the list of numbers that you want, and along with that you just pass the d type equal to int, saying that, hey, I want the data type of all the items in my numpy array to be of type integer. So you pass this, and then it makes it like an integers only, like 1 2 3, and 2.7 now became 2 and 69.98 became 69. So basically it did the floor of it. Okay, same thing, if you wanted it to stay as floating point numbers only, you could have just given d type is equal to float 32. Yeah, as you can see that when you gave float it became 1 2 3 4. Yeah. Okay. uh, okay, so this is good enough. But what and all are the types of data types that you can use with this np array, right? This you need to know at beforehand only. You can't just randomly give like decimal or something and it might not work, right? So some of the most common numpy data types are, you can go bool, which indicates whether it's boolean true or false, which is stored as a byte. Int, like what basically default whatever we give, right? Int, or int 8, int 16, int 32, int 64. These are basically just to store integer numbers with varying sizes. um, Another way is like to you another data type is the float, where you can have just float or float 16, float 32, float 64. Basically this just means how precise you want. Like a float 16 is like a half precision float, float 32 is for single precision float, uh, and float 64 is for double precision. Okay, so that is with respect to int float. You can even store have a complex data types, so you can specify complex. One second. Okay, you can specify it as complex 64 and complex 128. So these are like the most common data types that you will be probably using when you are using NumPy. Okay. um, okay, now that you know that, okay, you can create a NumPy array with a list of numbers and a given data type also. Let's see what more you can do with this. Let's create a NumPy array with 2 4 6 8 10 12 as some in a list, and store it in a variable called items. Okay, now I need to know what is the data type of this, right? When I type items dot data type, I get back the value as, hey, it's of type int 64. This 64, right, it takes it based on your machines, if it's a 64-bit machine, by default it will be like int64 or float64. If it's a 32-bit machine, it will be int32 or float32. That you can, but GPUs most often work with 32-bit only. So it's like if you are doing GPU based calculations, it's best to convert it into 32 and then send it to the GPU. Okay, fine, we'll come back to this thing. Okay, we have items is now a numpy array. It's a single dimension array, right? Like you can only see that, hey, I have only 2 4 6 8 10 12, a list of numbers in a single dimension. Okay, you can see these numbers over here, and you can find out what data type it is, that each element in this array, right, what type it is, by using the dot d type call. Once you call that, you get to know that, okay, it is int64 or float based on whatever you have defined. Okay, what are the dimensions in this? Like in this array we have only a single dimension. Single dimension means it's just one single row of items. There is not much. Okay, and then shape says you that, okay, in each of these dimensions what are the types. Like if in the next example when I explain you columns, I'll explain shape, but in this case we just get back the value of 6. um, then size tells you the total number of items, right, like the total number of items inside my numpy array. So in our case it was 1 2 3 4 5 6, so expected, yeah, we got back 6 items. Okay, now I want to know how much space that it occupies. So one item inside this numpy array will be occupying, how to find out like how much space it will occupy is by using this items dot item size call. When you call this function, it will return you the total size of each item inside this item list in terms of bytes actually. Okay, so you get back now in this case 8 bytes. And n bytes, if you call the function n bytes, it will return you the total size of all the items occupied inside this list. So we have 6 items, so basically 6 8, that should be 48. Same thing, it returns you back the 48 bytes. Okay, now let's say that we had to create for a multi-dimensional array. To explain you like this n dimension, we'll create one multi-dimensional array. Same 6 items are there, but you have 2 rows right now. First row has 3 columns, 2 4 6, and the second row has another 3 columns, 8 and 8 10 12. It will look like this. So it has 2 rows and 3 columns. Okay, okay, so what is the data type? It still remains the same in 64. Okay, what is the dimensions now? If you if you check the end by calling the enddim function, you will get to know that, okay, there are 2 dimensions to this. Previously it was only a single dimension because it was just a single row of items. Okay, here we have 2 rows, like we have 2 rows 3 columns, like 2 dimensions are there rather than just a single dimensional array in the first example. This one has 2 row, like 2 dimensions, rows and columns. Okay, so we get to know that, okay, there are 2 rows and 3 columns by calling the shape actually tells you how it looks actually. So it looks like this. So 2 rows 3 columns, cool. Now each of these row I want to know uh, like, yeah, we can get to know the size by calling the same dot size. It will tell you that, okay, there are 6 items totally, and then 8 bytes. Yeah, space that does not change by just putting it in the if single dimension or multi-dimension, this item size remains same, and the n bytes also should be the same as is over here. Okay, so what, right now you know that, okay, I can create an numpy array of items. I can check its data type, or while creating only I can specify its data type rather than numpy guessing it and upcasting it. I can give it on my own if I wanted. I can check the number of dimensions in this. That tells me whether it's a single dimension, 2 dimension, multi-dimension. And I can check the shape, like each dimension, how does it look. So in our case, for this 2-dimensional array, we got something like, for the row we have 2 rows, so that's why we got over here 2, and we had 3 columns, so that's why we got 3 over here. So yeah, but in case when we had just a single dimensional array, just for 6 items in a single dimension. Okay, then we can do the size to check totally how many items are there in my complete array, including the rows, columns, or what, everything. You will get to using the item dot size function. Then we could call the dot item size in order to get the size of each item in this array in terms of bytes. So in our case, this int64 was occupying 8 bytes of memory, and n bytes for the total size of the array. Okay, so yeah, right now you got to know how to at least get basic when you have an array, what you can do with it in order to better understand how it is. Okay, so we'll create like there are some other functions which help you actually create some arrays to get started with actually. uh, in first one is like you have this function called as np.zeros. If you say okay, I want an array with 5 items, but initially let them all filled with be filled with 0 itself. So what you would do is, instead of creating like np.array and pass 0 comma 0 comma 0 comma 0 5 times, you could just call np.zeros with 5. That way you will get an numpy array with 5 items and each of them being 0. Okay, um, you can check that same thing. This 0 array, if you call dot d type, you get to know that it's of float 64 in our case. This by default, the data type no, is set based on our machine actually. Float 64 it is being set, and it will be, yeah, as previously mentioned, on 32-bit for 32 machine. Okay, you got zeros. Similarly, they have the same kind of function for ones also. If you wanted a numpy array with filled with ones initially, you could just call numpy array np.ones and pass in what is the size of the array you want. You want 5 items in this, so you pass 5. Boom, you got 5 items over here. Okay, so now we are able to actually, this 5 whatever you're passing here, no, that is like the shape of the array. If you pass it a single number, it will be considered like a single dimension array with 5 elements. Later, yeah, here in this example you are able to see that I want a 2-dimensional array filled with ones, and the shape for it is I need 2 rows and 2 columns. So this will return me this kind of this output, like 1 1 and another 1 1 in another row. Okay, so this is np.ones with data type set with int. Okay, sometimes you might not want ones or zeros, you want to fill it with your own specific number, let's say pi or something, right? If you wanted to fill an array with only the numbers which you want, you can give np.full, the shape, followed by the number that you are expecting to fill the array with. So in this case, our filled array would be consisting of 10 items, and each of this item will be 3.141. So as is, you can see here, so it has created an array with 10 items with each one being 3.141. Okay, so now you know how to create some sample arrays to get started working with. You can create zeros, ones, or fill it with whatever data you want, unless you are reading this from some place, right? You need to have a basic placeholder array to work with, so that later on you can update it. Okay, so now we'll create one multi-dimensional array of 9 cross 9 with ones. Okay, you can see that it's created with 9 rows and 9 columns. Okay, now along with these basic functions like zeros, ones, you might want a little bit more functionality, like for you to get started with numpy arrays, right? Like you want some array to work with, but you don't want it to be zeros or ones or just filled with some number. Let's say you want it like a range from 0 to 50. If you wanted 50, 0 1 2 3 4 5 6 up to 50, then how would you go about doing it, right? So for that reason, we have something like in list we used to have create a list with range, right? You used to call the range function. You used to pass the starting, stop, and the step size for this range. Similarly, in numpy we call it as arrange. Just you put an a next to it, similar, something like that. So you just call it as numpy arrange. What this arrange does is, it takes the same thing. It's saying that okay, I have to start from 1, I have to go up to 30, and I need to go with each step size of 3 elements. So if I were to execute this, I would be getting back okay, I started from 1, I went up to 30. 30 is not included in this case, and I'm jumping 3 items once. So I got 1 plus 3 is 4, 4 plus 3 is 7. You kept going. Okay, this is good. There's another function actually called as the linspace. Linspace says that okay, now I want from 0 to 1, okay, both are included, but I want it to be evenly placed in between. I shall execute to explain it. Yeah, you can see here from 0 to 1, I need 5 items. Okay, so this array's length would give you 0 1 2 3 4, yeah, which means 5 items are there inside this array, but I need each of them to be evenly placed between each other, like 0 to 0.25 to 0.25 to 0.5, 0.5 to 0.75, and 0.75 to 1. So which means there is a 0.25 gap between each of these numbers, and there are 5 numbers inside this list. So if you wanted to create such an array, you would be using the linspace. So it's linear space, I guess. So in this will give you back an evenly spaced array. Okay. Okay, you could either you could do this. Another option that you have is, in order to create an array, you could just say, okay, just give me the random numbers, right? Okay, in NumPy we already have a function for that. That is called the np.random random, and you pass a shape. You are telling that, okay, I need 3 items over here. So you are getting 3 items between 0 to 1, which are uniformly distributed. Okay, so you got this. But let's say that, okay, I want the random numbers but with a fixed mean and some specific standard deviation. How would you go about doing that? You could do that with just in our np.random. Along with that, you could just call it with the, once again, yeah, ouch, yeah, you could call it with np.random.normal, saying that, okay, I want it with a fixed mean of 0 and standard deviation of 1, and give me the shape. You will say that give me the shape of the matrix is a 2 cross 2 matrix. So you get a 2 cross 2 matrix whose mean is 0 and standard deviation is 1. Got it? So okay, we can create some random numbers. Same thing. One more thing you could do is, like, if you wanted a random array of multi dimensions, there you can specify the shape also. You can, wherever shape we are giving a single dimension, you can just replace it with a tuple indicating your shape. Okay, so okay, you have random numbers with a fixed mean and standard deviation. Now I need random numbers which are in between a fixed interval, right? Like I want from 0 to 20 or so. If I wanted that, I could execute this randint. The function for that is np.random.randint. You could call this function with, you want to say that, hey, I want to specify interval from 0 to 20, and the shape of the matrix is supposed to be 2 cross 2. This will return you back a 2 cross 2 matrix whose elements are between this interval that you have specified. Okay, okay. And one more thing, like while working with matrices, usually you might want to create identity matrix or empty matrices, right? So to create an identity matrix with NumPy, it is quite simple. Like, they already have this function called as np.I. If you call an np.I with the shape of the matrix, actually this is like, it has to be a square matrix, right? Like, it will create a 7 cross 7 matrix in our case. So it will be like all the diagonal elements are all 1, and you have a 7 cross 7 identity matrix. Similarly, if you wanted to create an empty matrix, you could call the np.empty over here. So np.empty following the size, and it will return you back one array filled with, actually these numbers whatever are getting filled in this array are what is already existing in that memory location. It's not like NumPy is finding some like numbers and then populating it. No, it is just taking whatever is in that memory, it's just populating it over there. So yeah, this is to create an empty matrix using np.empty. So the some of the helper functions for you to, in order to get started with creating some arrays, are np.arrange if you wanted to use something similar to the range function, then linspace for linearly spaced, evenly spaced items, random for creating the random array. You could specify with normal in order to say fixed mean and standard deviation, or randint if you wanted with a interval. You could use np.I if you wanted an identity matrix, or np.empty if you want to just create an empty array uh, filled with items whatever is in that memory location at that moment. Okay, okay, so this gives you like all the basic functions and methods that you can use along with NumPy array. For example, let's say that with this you can just understand, okay, how an array looks. Let's work with one example to see how to do it. Let's say that we wanted to create this Sudoku, right? This Sudoku matrix we wanted to use in NumPy. Step 1 is we'll create this Sudoku matrix has 9 rows and 9 columns. So each of these 9 rows are represented over here. So there are 9 lists over here which has 9 items in each of those lists. And after calling the np.array, we get to see that okay, we have a 9 cross 9 matrix over here. If we check its dimensions to confirm what our theory is, okay, there is 2 dimensions. Yes, rows and columns are there, and the shape of it is there are 9 rows and 9 columns inside it. Okay, and the total size, like, yeah, the total size is 81. Yeah, 9 cross 9, 9 and is 81 items. Okay, now if I had to address the first row over here, right, how do I do it? It's quite simple actually. This follows all the conventions of our list, whatever for list indexing what we use in NumPy matrix array. Also you can use the same conventions. Okay, uh, okay, we'll call this matrix as Sudoku matrix, and if we specify 0, right, it says that I want the 0th row and all columns, like it's similar to something like this, like you're saying that I want everything in the 0th row, and so 0th row is this and all the columns inside it. So you specify with empty, or you put a colon over here. Okay, so this returns you back 300801002, which matches with whatever is in the first row of this matrix. Let's say that you wanted only the first column in this matrix. You would just do exactly opposite to what you did above. You would say that okay, give me all the rows, but you give me only the 0th column as here. So what you will get is 320807096. Cool. So you have to specify like row, the dimension, right? Like you want the all the rows followed by specific column in this case. Okay, let's say that we wanted to address this middle quadrant, whatever we are having here. No, like there are 9 blocks here. I wanted to address the 1 2 3 4 fifth block, the middle center part of the Sudoku, which consists of all the zeros over here. In order to address that, we need to first understand that everything starts with 0 over here in this NumPy array. So it will be like 0 1 2 3. So I want from the third row and third column up to 4 5 6 3 4 5 6 up to the sixth, because it's excluding the sixth, right? So you want to say that hey, give me all the items from row 3 up to row 6. So this will give you the third, fourth, fifth rows, and in the column space you will say that okay, give me all the columns starting from third, fourth and fifth up to the sixth, right? So basically 3 4 5. And if you print this middle matrix, the one whatever we are looking for, you will get the matrix that whatever we are trying to get, right? So this is how you will be addressing some parts of the matrix. Like let's say this was like a huge image which consists of people, and if this was the part whichever you are looking for is their face, in that case you would just crop out their face. In the example of face recognition, you would pass only the face part of the entire image in order to go recognize who this person is. So it is good to understand like how to first take the part of the matrix that you are looking for. Okay, now that you have this part of the matrix and you're storing it this in this variable, you need to understand that this is not a copy of this matrix, right? You have, even though you have mentioned this, and when you print this, you're getting 0 0 0, the matrix part that you're interested in. Let's say that you were going to set the 0th element to 20. You would assign it the value 20 by just addressing that, just same similar to how you would do it in list. And here you are saying that okay, the 0th element is 20, print this matrix, you get 20 over here. But if you go look at your original array also, you will get to know that hey, this item got changed to 20. In some cases this is good, because instead of keeping multiple copies of the same kind of the original data, right, it's better to work with parts. And then even though, because they are written as views, whatever you work on the smaller part will affect the entire huge data from which you took it. This is good in those cases, instead of keeping multiple copies of this same data. But let's say in your use case you wanted to keep it like, no, I wanted just the copy of it, I don't want to keep a view of it. In that, all you would do is you will say that okay, give me the matrix from the specific portion of whatever you're looking for, but you will say dot copy. By saying it's a dot copy, your mid matrix, whatever you're having, right, even if you update it's basically the copy of it, like you took that items, copied it into this, so it is not like a reference. So if you update this matrix, whatever you have just created, it will no way affect the original matrix. Based on your use case, you can get to choose whether you want to keep a view is good as long as you want to affect it, make sure it affects the original array, or you can use a copy based on actually your use case only. Okay. Another numpy arrays function is called as the reshape functionality. How you would do this is, let's say that we wanted to get this sudoku matrix, right? But initially you are not given 9 lists which contain 9 items each like this. You are not given, but you are given just a list which contains 81 items, but you wanted to then convert that 80 list of 81 items into a 9 cross 9 matrix. So if, because you might be reading some from some list of numbers, so if you were in that situation, numpy gives you that option called as resize. So here in our example, same numpy array is in, now we are having a list which contains 81 items in a single dimension. Okay, we get to see that by endim, which says, yeah, this is a single dimension and that dimension contains 81 items. We could use this dot reshape function which returns you back the same view only. Okay, which gives you back the 9 cross 9 matrix. We are saying that, hey, I want to reshape it into a 9 cross 9, so it returns you back the same matrix that looks like that our sudoku matrix above. And remember, this is still the view, which means if you update any one item inside your view, it will affect your original matrix. Okay, so now you know how to create a numpy array, how to address its index or make a copy of whatever part of the matrix that you are looking for. Usually you will be working with multi-dimensional arrays, so it should be easy by addressing it from the dimensions. Okay. There is another option also, like another thing that you'll be working on with arrays is like you might have two arrays. In our case we have 1 2 3 4 5 6, which is an array A, and another array B which contains 7 8 9 10 11 12. Okay, now you want to join these two arrays, right? Like in list, if you add two lists, you can just use the, if you wanted to append it as another dimension, you could just use the dot append, or you could just add it up. But in numpy we have the dot concatenate method which says that, hey, I want to concatenate this array with this array, and in the end I am expecting that it should contain all the elements from 1 2 3 4 5 6 and 7 8 9 10 up to 12. So 1 to 12 items, you would just use the np dot concatenate, and inside you would pass a and b, the items that you want to concatenate. Okay, so this makes sense, like you can concatenate, like, but with an, let's give with an example, I shall explain you more features of this concatenate. Let's say that we have a square matrix of 0 cross with filled with zeros of the shape 4 cross 4 matrix. So what I'm expecting to see here is a 4 cross 4 matrix filled with zeros. Yes, that is correct here. Okay, and then let's create one more row which contains 1 2 3 4. Now I want this row to be appended to my square matrix. Like initially it was a 4 cross 4. Now when you add this, the intention is it becomes 5 cross 4, right? Because it becomes another row which gets added in the bottom. So it will be 0 0 0 of 4 rows, and the fifth row will become 1 2 3 4. In order to do that, you could say that, hey, I want a numpy concatenate. I will concatenate the square along with this row. Okay, you give that in the square basis basically to say that it's a multi-dimension, because this is a multi-dimensional array. This also should be that, right? So you're going to say that, okay, after concatenation 1 2 3 4 has come in the bottom. Now let's say that you want to make this 1 2 3 4 come as columns rather than the row, meaning instead of 0 0 0 0 4 rows and the fifth row being 1 2 3 4, you want the last column, the fifth column of this should be this 1 2 3 4. In order to do that, first you need to reshape this, because when you concatenate you should make sure that their dimensions match. If you're going to append it to its row, you need to make sure that uh, it has the same number of columns, and if you're going to convert it to add it to its column, then you need to make sure that numpy array has the same number of rows. Got it? So in our case we have already 4 rows existing 0 0 0, so we just need to reshape this 1 2 3 4 to 4 rows with one column each. So basically you'll get 1 2 3 4, and that you're going to concatenate in axis 1, that is your second dimension. You're going to concatenate it, which will give you 1 2 3 4. Okay, so this is a simple, I mean this is a way to do it, but multiple times you might forget to use this axis equal to 1, or for more simplicity and more understanding, you could use the alternate function called as vstack. Vstack says that, hey, vertically stack it, which is much more understandable. You know that, okay, this is going to stack it vertically, which means if you pass me an numpy array and another row, I will just add it in the end, so you get to see that 1 2 3 4 got added over here. Another one such utility function is this hstack, which would say that give me a row, give me a matrix, I will horizontally add to it. So now you got to know that 1 2 3 4, instead of using this axis is equal to 1, right? This makes much more sense, like np.hstack and np.vstack. Vstack is for vertical and hstack is for horizontal. There is also another function called as dstack, but that is for the third axis if you were working with a 3-dimensional array. Okay, if you know how to join them, you should also figure out how to split them up, right? So we have this function called as np.hsplit. Hsplit says that horizontal split. Okay, and whatever you give over here, right, as your second, you first need to give the matrix that you want to split, and the see, when you are splitting it horizontally, you need to tell that go up to the specific column, right? Like if you go from left to right in this array, when you are going to split it based on horizontal, you need to say that which up to which column you go to. So in our case, the Sudoku matrix, whatever we were having, once again I shall print it again so that it makes, okay, so in this Sudoku matrix, you are going to say that go up to the fourth column, 0 1 2 3 4. You're saying that, okay, go up to here. So this is one split and this is another split, like 0 1 0 0 2. Same, you can see that over here, no? So yeah, horizontal split will say that, okay, I will go for every row, I will go horizontally, I will scan up to this fourth column. So I'll go from 3008 and stop 2010000002 like that. I will go horizontally scan each row up to this column and give that as one split, and the other split will contain from 4 up to the ending, unless you can specify more in order to see if you want another split also. So this is how head split works, like for horizontal split, and V split is for like vertical split. You're saying that, okay, go with the in our Sudoku matrix, you're going to say that traverse from top to bottom up to the point whatever you have mentioned here. You're saying 4, which means that go 0 1 2 3. Okay, I want all the rows from 0 to 4, and 4 5 6 7 8, these will come in the next split. So basically this is horizontal split and then vertical split. So this is how you would split. It will return you back 2 arrays which contain the splits that you are looking for. So yeah, this is how you would work with array split and concatenation. So for now you have understood, okay, if you have a numpy array, if you were to start with a basic list of numbers, how to convert it into a numpy array, check its dimensions, convert it by reshaping it into whatever shape you want it, and then you could concatenate if you want, or stack it, and then even split it. So with this you will be able to at least basically work with getting the array that you are looking for. Like you have a list of numbers, you can convert it into an array of the shape and size that that it is intended for, right? Okay, fine. So this is like the basic part of the Numpy module. Next we will see about U functions and the other things that you could do with Numpy arrays.